So make a new Max patch, open up Max. If nothing appears on your screen, remember that you need to go to Max New Patcher at the top. And it should open up just fine for you. Okay, and when we're there, what we need to do is we need to make our setup for digital audio. So that means that we need to have our easy DAC. I'm going to make this bigger so you can see it. That object is N for object, and then easy DAC tilde. And I'm going to make it bigger arbitrarily. And then we need a meter. So we're going to have live.gain, which is my favorite one to use. Not the only one, but the one I like the best and I think is the friendliest. Let's plug in our live.gain tilde object with these two furthest leftmost outlets into the Easy DAC. And it doesn't matter if it's on or not right now. Doesn't matter right now for our purposes. Okay, so that's basically what we need for right now for our digital sound rig for now. Now let's make a keyboard object that transmits MIDI data. Yes, question.
I just opened this up. I don't know what to do.
Okay, so you go to the top where it says File. I'll do it with you. Top where it says Max, File at the very top. And you click on File and you hit New Patcher. And it's going to open that window for you. And then once you're there, you need to make, I'll write these out. You need to make an object called easy DAC tilde. And you can access an object by clicking up here where it says object near the top, or just hitting the letter N. Remember, to create objects, you need to have the patch unlocked. That means unlocked down here. So that's the object easy DAC. This one is the object live.gain tilde boom. And then you're going to connect them as such to look like this. Okay, and once you're there, you're caught up with what we're doing right now. So, okay, so from here, what I want to do is send MIDI notes into an object that produces digital audio, and then we're going to play with some effects, and then play with some stochastic means to alter those effects. Okay, here we go. Make a new object with me called K-Slider, and it'll autofill. K-Slider. And it's going to produce a keyboard. Hooray! We're going to make a change to this so we don't go crazy later. We're going to make an attribute user interface object. That object is called ATTRUI. Attrui. Attribute user interface. Hit enter. Yes, it is created. It says nothing. It says nihil. And then you're going to plug this one into the K-Slider. Now do this with me. This will be important for later. If we lock the patcher now, we can make changes to the attribute object. Let's make the display mode. So what I did was I clicked on this part where the arrows are, and I found display mode. And it just reads as Depeche Mode right here. And I click on it, and then I click on touchscreen is its little modifier over here. This side, display mode. This side, touchscreen. Doing okay so far? Okay. So then let's create some integers so we can see our MIDI notes. That's integer I and integer I. We need two of them. One for the left outlet of the K-Slider object, and then one for the right outlet of the K-slider object. And so yours should look like mine. If yours is working correctly, when you click in here, it'll change the numbers. Notice that the way that we have this configured with the touch screen modifier, it means that as soon as we lift up our finger, the velocity returns to 0. This is kind of like a cheap way to do a note off kind of command that's like built into Macs with the keyboard. So yours should be behaving like mine, I hope, where when you lift your finger off, it returns to 0. That doesn't seem like a big deal right now, but it will be. Question. Why doesn't the other one move? It does move. That's a good question. Can someone else answer that question? It is the pitch. It is the pitch. And so remember that that pitch value can be retained. It's a good question. The pitch value can be retained, but it's actually the velocity value that's going through that determines whether the note's going to be on or not. So we can store like a tacit 36, but it has no velocity, so nothing's going to come out. But the 36 is stored. Does that make sense? Yeah. I think also we wouldn't want it just to automatically return to pitch 0, because also pitch 0 is not nothing. Pitch 0 is a note in MIDI land. Okay, anyway, did I answer your question? Okay, thank you. Now, we're almost there. We're almost to the part where we're going to make cool sounds. Almost there. Let's make an object called pack. And what we're going to do is, you'll see that pack has 2 inlets. We're going to send pitch into the left one, and then velocity integer into the right one. Like so. And then make an object called MIDI format. MIDI format. Boom. And then we're going to plug pack into the first inlet of MIDI format. Now, why are we doing this? If you read on your screen, it's really small on my screen, but if you read on your screen, if you hover over that first inlet of MIDI format, it gives you valuable information. It says note on or note off, list pitch velocity. We're actually sending it a list. That's what the pack object is doing, is it's taking these 2 numbers and it's making them into a list of 2 integers and then sending those 2 integers into MIDI format to be interpreted by another object we haven't added just yet. Because remember with our experiments with make note and note off, you need 2 pieces of information at the very least to get the thing to sound, which is pitch and then velocity information. So that's actually what we're doing. So imagine it with me. When you press one of these, 2 numbers pop out. We're putting them into a list, sending it to an object that can interpret the list. That goes to an instrument that doesn't exist yet. Okay, we're almost there, and we're going to make cool sounds. I promise you. Now, we need to make an actual instrument, because we actually don't even have an instrument yet. No instrument exists yet. So, follow me. Go over here with the cursor and go to plugins. It looks like a plug over there on the far left side, your left side of the screen. And we go in here and click on plugins. A little list pops out. Some of these are effects, and some of these are instruments. I want us to use Big Ben Bell for right now. Let's use Big Ben Bell. And so we click it, drag it, make sure your patch is unlocked to do this. If you click and drag it when the patch is locked, it won't do anything. So we want to make sure the patch is unlocked. I'll do that again. Patch is unlocked. Click on plugins, live device, Big Ben Bell, click, drag, boom. Okay. So I want someone to tell me, if these inlets are numbered 1, 2, 3 on the top, which one is going to accept MIDI information? I want you to scroll over them and then tell me which one will accept MIDI data. The third one. Yes, exactly correct. We scroll over number 1. Nope. The princess is not in this castle. It says signal, channel 1 in. This one says channel 2 in. This one says MIDI in. Why does that matter? What are the first 2 channels listening for? Listening. What are they able to accept? Well, it kind of told you in the parentheses. Scroll over it again. It's listening for signal. No relation to the app of ill repute. So, it's listening for digital audio explicitly. But we're not doing digital audio up here. We're doing MIDI. So, let's send left outlet of MIDI format, MIDI message output, boop, over to the third inlet, the MIDI in inlet. Okay, one more step here. Now, can anyone anticipate what the last step is to get sound here? You got to connect it to live.gain. And we're going to connect now. You might be thinking to yourself, Dr. Welty, are we connecting some kind of MIDI thing? It's like there is a MIDI out, but no, because live.gain is listening for digital audio, because the Big Ben bell is actually an instrument and it's producing digital audio for us. So we're going to then, boop, plug it in over here. These are 2 signal outlets. I'm going to lock the patch, turn on the sound, and it lives. And you can change these things too. I'll turn down so we don't get like overload in here. So you'll still make sound, but it'll be just a little bit quieter. So, yeah. Now you can play with these buttons. I encourage you to like extend the attack. Hooray! It works. Now I just want to recap, because actually this is one of the important lessons that Max kind of helps us see, is that we have an object that's spitting out just numbers, just integer data, and then those integers are put into a list that is kind of midified, right? That it's recognized as a pitch and velocity list of numbers, and then it's formatted here. It goes into an instrument that is accepting MIDI input. Inside of here, behind the Liberty Bell here, it is actually interpreting the pitch and velocity input, and then sends out digital audio that is heard over our speakers, that is converted from digital to analog, I should say, with more specificity. Does that make sense so far? Yeah? Hooray. Okay. Now remember, when the patch is locked, this is a slider as if on a mixer. So you can raise and lower the volume of the live.gain object. Okay, well that's neat. But I promised you something more with effects, didn't I? I did. I touched on this last time. Now, we could use some of the, I'm presenting this as a possibility, one that we're actually not going to realize today. But You could click on plugins and then use some of the objects in here. Those are cool. Yay! If you want to use the Warpoon, that's up to you. So what I'm going to do instead, though, is I'm going to create objects like, and remember I did this kind of last time. I touched on this. If you create an object and type ABL, you will see a list of ABL.device and also ABL.DSP. What does DSP stand for? Anyone want to guess? Anyone want to guess? DSP? Yeah, what does DSP stand for? Digital Service Provider. Yeah, no, that is one definition. In this context, right, if you actually Google search what does DSP stand for, you're more likely to find that answer, right? And that's a very computer internet land answer. And you're correct. But in this context, digital signal processing or processor, but processing. So basically it's modifying the digital signal. But hey, I'm going to tell us to use one for now. I'm going to tell us to use a certain one. Let's use the, we started playing with the delay last time. I want to return to that. So this is abl.device.delay tilde. And you'll find it in that list of objects. Okay, I'm almost out of coffee. Oh no. Okay, so, well, how do we use it? Because it doesn't appear as though there are any affordances given to us. You might be asking yourself, where are the knobs? Where are the buttons? What do I do with this? Well, let's investigate the inlets and outlets first. The inlets say left channel, right channel, and then feedback. Okay. Down here at the bottom, the outputs say left channel, right channel. Now, listen, this is important. In Macs, notice that Big Ben Bell told us it was listening for signal. This one doesn't say signal, but I assure you it is. The thing in Macs that's telling you this is a digital audio device is the tilde. The tilde Swinton on the end of the object name, right? That is telling you this is a digital audio thing. Also, the cables are a different color. You notice that? We went from this like gray drab thing to some kind of exotic snake down here. And this is indicating digital audio. This is indicating math. This data. Okay. So, wait a minute. How can I, using Macs, how can I figure out how to do things with this little box here? Let's say I wanted some help. Where would I find that help? How do I get to the help? We can right-click on it with the patcher unlocked, and then hit open abl.device.delay help. And then it opens up this thing. Let's investigate this. Let's investigate this and see if we can understand better what is actually happening. Does someone wish to try to explain to us how this is working and what's happening? And I mean just kind of stating the obvious. I'm not asking you how the inner workings of abl.device.delay are occurring. But notice that in this help we have a sound that's called drum loop. Turn on my sound, yes. Okay, so the loop is playing, and look, we've used these things before. What were these little boxes called? We made one for our keyboard, didn't we? Yeah. Attribute user interface. Attrui. Well, those guys are plugged in to the first inlet, and when they do that, it autofills them with information. So if I click on some of these things, it starts to make changes. Why is it still playing? Huh? What? This is a little different. I told it to stop right here. It's not MIDI. This is digital audio. Can someone... The feedback is up. The feedback is up. It's sending the signal back into the loop. And then these delays are also so long that it's going to sit here and keep going. With the feedback at 0.95, will it go on indefinitely? No, but it'll go on for a very long time. And so if we get rid of these things, there it goes. And it's gone. Yeah. There we go. So notice that when I change the delay speed very suddenly, I get these like leftover things, right? Wait. What's going on? What are those extra sounds? There were no bleep bleep bloops in this sample. There were no bleep bloops. What was happening? Anyone want to guess? This object is behaving kind of like a tape delay. And when we extend the delay time and then reduce the delay time, it's basically changing the speed of the sample in its own way. And that's like the beep beep, the little bleep bloop we heard was actually part of the sound being compressed so quickly, so small that we ended up with like an actual pitch. The thing I'm actually talking about is time stretching. So if I go in here, check it out. This is important for this object, and this kind of thinking will apply to any object that we engage with. Let me see here. I'm trying to remember with this one particularly. Dooby-dooby-dooby-doo-boo. Give me 1 second. Here it is. So we have delay transition mode. And in this case, it was repitching it, right? But if we change it to like fade, let's see what happens. Jump. There we go. So notice with the jump, we're not encountering as many of those pitched artifacts. Now there's other things that can be played around with here for certain. Yep. If you look over here, yeah, this is what I wanted. This is what I wanted. So check out. If you go on the, I'm gonna turn mine down for a second. If you go on the top to smooth mode, this is the guy I was looking for right here. It's actually, it's in the attributes. But where are you? No. It's in delayed transition mode. And you can change it. So we had repitch, fade, and jump. Anyway, these are ways that you can play around with the delay device. Filter modulation, I'll leave that for you to read if you wish to. Let's go. Don't save the help. I closed the help file. And now, let's go over here and let's insert this into our signal path. Now, this is an important concept, not just for Macs, but for DAWs as well. What do I mean by signal path? Anybody? Signal path. A pathway that the signal traverses, yes. That's, yeah, exactly. Okay. Okay, can we elaborate on this? Well, think about it. We have a signal path right now, don't we? What's our signal path right now? No. Well, okay, wait a minute. I misheard you. I misheard you as CHORDS for some reason. But okay, so cords. You meant like cables. Yes. Okay, yes. I misheard you. Because I'm primed for music stuff. So, yeah, there's some kind of signal going through these virtual cables, right? But I wish for us to state the obvious. What does our case slider put out when we click on it? Does it put out signal? It's putting out information. It's putting out data. That is then being put into a list and made into a list that this object that creates digital audio can interpret. So data, goes into this thing, turns it into signal. Now it's plugging into what we basically have is like a master output for everything. Everything's going through there. I know it's only one thing, but that's what we have. And then it goes to our digital to analog converter, and then we can hear it through our speakers. I want to insert the device.delay into the signal path. That's why I'm asking you this question. I'm going to insert this into the signal path. So I'm going to plug in channel 1 and channel 2 into left and right channels. Now, because I want to modify certain things on here, like on the go, I'm going to make an attribute box, and then I'm going to Command D, and just make a bunch of them. Just to duplicate. Then plug them in to the leftmost. Plug it into the leftmost. Bum, 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 bum. Plug it into the leftmost. I know it still says nihil right here. So then you click on it, and you can, I would suggest making like delay times for sure. I don't know. Feedback. Feedback seems pretty important. Ping pong mode. Yeah. What else could be cool? Yes, dry wet. We need dry wet for sure. And then, I don't know. Delay time modulation. Fine, sure. Great. Now, you can make them whatever you want, but I strongly recommend that you have at least feedback and dry wet in there, which is the one called mix, but it looks like dry wet in the drop-down menu. The other ones are all fun and games, but why does dry wet matter? What are we talking about? Talking about Tex-Mex? What are we talking about? Dry wet. Huh? Like reverb? Keep going with this idea. Like reverb, how? Because reverb will use something similar. But what's it describing? I love the Oki burrito at Las Palapas. Because it's, yeah. I know it's like white people burrito, but whatever, I don't care. I like it anyway. So, okay. So dry wet. What do you think that's describing? Well, if the signal's dry, it means that there's no effect on it. If the signal is completely wet, it means it's got the sauce on the burrito now, right? It's got the effect in there. Some objects, and we're going to see this in DAW land too, some objects will do stereo and we can get a dry and a wet signal together and then mix those two together. Some objects, like this one, it's just asking us what's the percentage of saturation of the signal. Okay, so I'm just letting that sink for a second. Let's plug in our device to our live.gain. And for those of you wondering, I know this is like a sea of cables. Let me clarify this a little bit. If you ever want to reorder cables like this, where I kind of made it auto organize them, you select a cable and hit Command Y, and it will check it out, Command Y, and it kind of makes it a little more organized. Some people are into that. I don't know. It can make things look a little neater, so it's not just like, I don't know. Yeah. Okay. Let's find out if it works. So I'm going to use a low feedback. Ping pong for sure. That mix is fine. And I'll increase the times. I'm going to lower my attack so I have a definite start to the note. There it is. So to make it a little clearer, I lowered the attack time on my Big Ben bell. The attack time is how long does it take for the signal to reach the top of its volume, like a slope. If you put it at 0, it's completely immediate. That means you click on the key and the sound is right there. Now, if you lower the attack, I think that the delay effect will become more apparent. Okay, yay, that's cool. That's neat. Cool story. Now, I also promised you stochastic processes. What do I mean by stochastic? Huh? No, stochastic. Stochastic. Here is I'll say this, sometimes in the news, you might read or hear about something people sometimes call stochastic terrorism. What is meant by that term? Because there's a context clue in there. Not saying I support anything of this nature, but I'm saying that It's the idea that something is random. It's the idea that it's random. It's happening by chance. It's not being predicted, etc. So we actually have very useful stochastic kind of dealios in here. So let's do this. Let's make a random. Let's make a just random object right now. Now wait, I have a question. From what you can tell, are the parameters for the device.delay object using integers or floats? Huh? Floats. Yeah, and it's right there. Remember? They're decimals, they're floats. Right? Okay. So, that means that our random object, well, it needs to be a float. So if I put 1 dot, and it took away the 0, it's fine. And then I put a float down here. Let's do this. And I'm making a bang, a random 1 dot, and then sending it into a float object. And look, every time I click on this, it's giving me a float. So what if we send this into delay? That's right, I'm plugging this straight into delay. Now, it's going to modify both of them, but that's fine. I don't care. That's okay. So basically, it's changing the amount of time. Every time I hit that random, it changes my delay time. Do you hear that? Number go up. Number go down. Number go up. Number go way down. It's practically a slap back. Yeehaw. So, okay, that's neat. But wait a minute. I want to go another step further. I want to create a little bit of chaos here, right? How would I modify my patch with 1 cable to send a new random integer into delay every time I hit a key? There's 2 really good answers. I'll reframe the question. I'll say it again and try to reframe it. How can I get my patch to send a random float each time I press a key on my keyboard, on my little K slider? I love how that delay thing is just still going on someone's computer. I'm fine with it. It's still going. It's like radioactive decay. That's a great name for a plugin.
I remember that we connected like a thing to like a metronome or something like that, to where like it would like send like random stuff, but I don't know how we did it.
Yeah, this is good. We're thinking about it. Well, what happens every time we press a key on K slider? It sends, I heard velocity difference. That's true. Every time you click on this, it might not be apparent, but it's sending a bang also. Look, when I hooked up a bang to the leftmost outlet of the K slider, and then every time I click it, it sends a bang through the system. That's because updating the integer value is also a bang. Updating the integer value is also a bang. So, what if I connect this here bang over here to this here bang? And then I'm going to command Y just to, I don't know, make that, okay, whatever, it's fine. Notice that when I lock the patch, all the objects come to the front and the cables go behind them. Okay, it's a little thing, but Yeah, it lives. Check it out. So now, every time I press a key, oh, even better, because look carefully. My apologies, I overlooked one little thing. This object behaves this way. That click down sends a bang, and when I lift, it also sends a bang. Because that velocity goes to 0, so it's also re-engaging that. So, well, I did accomplish my goal. Yeah. Oh no, it crashed. It's also because I'm recording my video, and it takes up resources to do that. I'm not worried about it. Recover edits. Cool. Okay. Yes, this can happen, particularly when your system resources are being taken up by recording a video. That's a thing that happens. So just be aware that your computer should be just fine because you're not recording a video that's... Can you believe this video file is almost 4 gigabytes already? Brutal. Okay, anyway. So it works. How cool is that? Pretty cool. What are some other devices we can play around with? Well, object abl.device. There's distortion. Sick. There's also an equalizer, 3-band channel equalizer. Compressor, which is pretty cool, but we're not going to worry about that just yet today. Stereo chorus. Let's choose one. Which one should I use? I can veto your decision. Yes. Which one? What? Stereo what? Let's use the stereo chorus. Let's see what happens. Okay. Now, each one of these, what I want to do first is investigate what are its inputs, and its outputs are just 2, of course. Now, yeah, we're gonna get into some trouble here. This is gonna be great. I'm excited. This is exciting. So I'm gonna click on the help first so that I understand what this thing can do. Yeah. Remember, if you're making that sound, you can lower the volume over here or on that live gain. Okay, so it's making a sine wave at 440 hertz. This object is up here. And then we can play around with these parameters. Aha, do you hear it? Wait, check it out. When I change okay, so great. So that's what it does. Now, wait a minute. I have a question. Take my glasses off dramatically when I ask a question like this. Does the order of the effects matter? Yes, why?
If you want certain delays to be activated on something, you can put it beforehand, but if you don't want it, you gotta put it afterwards.
Yeah. So yeah, it is. That's actually that's well stated. It's an order of operations, right? Because that's how we can think about the signal path. Is that, well, I know it's a bit obvious, but it's not. I'm not saying you said this, but just to clarify for everybody, we think about order of operations as like, obviously PEMDAS, but this is a situation where, of course, the order of operations means the signal path is going through this thing linearly, this thing, and then this thing, and then this thing. So if you have a bunch of ping-ponged delays, and then it goes into the chorus, right? The signal that has all the delays is now getting the chorus effect added. Or you could have the chorus first, and the signal is chorused out, and then that's going into the delay. This gets more dramatic the more effects you have. People think about this particularly with, of course, compression, and which we'll talk about later, but also like distortion and overdrive effects. Thinking about almost like it's exactly like guitar stomp boxes. If anyone's ever seen a guitarist using pedals, it's that same idea. The signal flow is going in a particular direction, and it does matter. Now, I'm not here to tell you in this class right now that there's a right or wrong way to do it. Nope, not interested. When we get to recording, there's opinions and live sound ideas as part of like an addendum to the recording. There's particular ideas about which things should go first, yada, yada, yada. But here, I want you just to experiment. So to insert this into the signal path, we need to get rid of that. I'm going to put the delay into the chorus as an arbitrary decision. And then I'm going to send the chorus effect to the live gain. And then I need to make attribute boxes. Boy, that sound just keeps going. And then I'm going to plug in all these attribute boxes into the chorus. Yay, hooray. And then I'm going to dry wet, and then I'm going to feed back, and then I'm going to do the gain. That makes sense. And then I'm going to do warmth. I like it a lot. Let's do stereo width. And then, let's do this real fast. Yeah, whatever. Ping pong. Great. Rock and roll. Rock and roll McDonald's. Okay, let's see. There it is. Sick. With the feedback and the warmth. But wait, I want one of these to be modulation rate. Yes. Okay, cool. Now, I have a couple more things to point out here. So, you might be asking yourself a question. Is that my computer that's making that sound? And the way you can find out is by looking down here at this meter. This meter is telling us audio meter, but it's also telling us CPU meter. How much of the CPU is being used to do the things on the screen. And if you have sound going on right here, your device is making sound. So if it's lighting up blue, your device is making sound. So, not trying to single anyone out, just, okay, anyway. If yours is lighting up, I recommend that you turn it down just for the time being. And you can turn it down right here by just grabbing onto this little dot and sliding it down. In the corner. I can't make it bigger, I'm sorry. I can move it to the center of the screen though. I can and do this. Okay. I'm gonna lower it, everybody. There we go. It doesn't tell me, I don't have enough signal coming through here for it to show me which terminal is doing it. Anyway, that's okay though. So that's neat. With these random dogs, I can plug them in anywhere and have it send random information to any one of those parameters. It's kind of up to my design, how I want to do that. You can think to yourself, wow, the possibilities are I don't want to say limitless, but yeah, kind of, right? Now, what I want to do, I want to talk about this. So we have an object, what is it called? I'm forgetting. No, it's not that one. Give me a second. I'm just forgetting its name. It's just called preset. Okay, I thought it was, preset. Silly me. So there's an object called preset. And you can make it however big or small you want to. But let's look at the way it behaves. Preset help. Okay. Preset help. Now, let's take a look here. This one's pretty neat. I can change these things. And these are not hooked up to anything. They're just buttons right now, right? And I could say, store this information in slot 1. That means that when I click on slot 1, it'll return to this preset. So let's change things again. Slot 1, boom, it returns. Slot 2 already had information. These ones don't have any information. Why would this be useful? Well, I'll tell you what, let's return to our patch. So I have arbitrary boxes here. But let's say that I really like, for some reason, I really like these settings. What I can do is I can shift click and then store these settings in cell 1. But then I'm going to go and change them again because I've changed my mind. But I don't want to lose cell 1, right? So I'm just making changes. I'm making changes you can see. Yep, great. And then I'm going to store these. I like these ones too. This will be cell 2. Great. Now, with the patcher locked, if I click cell 1, it returns to the original. And with number 2, it goes to the new ones I've set. It's basically taking a screenshot, more or less, of what the settings are on the screen at that moment in the patcher, and then switching between them. Do you have to use this in your homework assignment? No, but it's pretty cool. It's pretty nifty. One more thing. Let's make a little drum machine. We'll make another object. There's a cute little drum machine that's already built in here. We're gonna use where was it? Is it right in front of me? Analog drums. Thank you. Analog drums. So go to plugins, live device, analog drums, bring it over. Okay. So it doesn't do anything just yet. I know that. I'm going to move it down here just so it's closer to my, you don't have to move it. I just want this to be in a place where I can get to it. And I'm just going to plug it in dry to live.gain. We can leave all this other infrastructure over here for Big Ben Bell. We can just leave it. It's fine. Now, analog drums needs information to operate. What kind of information do you think analog drums will require to make sound? Well, what did Big Ben Bell need? It needed MIDI data. Analog drums is also going to need MIDI data. Now, there's something here that's a little hard to see, but I'm going to zoom in. This one's already set up to have a kick drum on C1, a snare on D1, hi-hats on F sharp 1 and A sharp 1, and toms on F1, G1, A1. What does that mean? The sound is mapped to those notes on the keyboard, so that if it receives C1, it's gonna send a kick drum sound. Okay, well, how do we send it a C1? Well, you have multiple options. We have multiple options here. So let's do this. Let's make a case slider. Another case slider, integer, send it a velocity integer, why not? I'm setting this up exactly as it was before, and I'm going to use the attribute user interface. I'm going to move quickly because we're short on time, because we're always short on time. Touch screen. Really wish this class met twice a week. Anyway, I have no power over this. Here we go. Pack. You guessed it. MIDI format. You guessed it. Boom. Boom. Oops, not that one. I want to use that one. Boom. And let's see if it lives. Let's see. Oh, I turned everyone down. Sound's still there. That's fine. I'm getting audio, but I'm not hearing it. Oh, I know why. Yeah, there it is. Okay, cool. It works. But wait a minute. This is a little inconvenient to actually like play the drums by clicking on a keyboard. Can somebody think of another way that I could design the patch to make it so that, I don't know, I either click a bigger button or maybe I even press a key on the keyboard? We can use live.grid to send it like sequential data. That's true. We could actually, that's a good idea. We could actually use our MIDI machines, our sequencers that we made earlier, and you can copy and paste those or recreate them from your screenshot submission and then plug those in with this pathway into analog drums, then out to digital audio. That's true. But I want to make something that's very interactive. Well, let's do this. We know that the drum sounds are living over here. The drum sounds are living over here. So we have toms right here, hi-hats right here, snare there, boom. Okay, so the numbers I need, check this out, watch this. Here we go. I'm gonna do 36, because I got my kick drum on 36, yep. Snare is on 38, message 38, you betcha. Okay, what else should I use? Let's use this one, just these three for now. Just keep it simple for now. 42. 42. Cool. Now, it's cool. It's very techie in here with all these bleep bloops. Okay, so I'm making buttons, bang buttons. They send the message. That's cool. But then I also need a velocity. Let's put the velocity at 100. And they also all go into the same velocity. Okay. And then let's send these into the pack, into the list maker. Yeah? Cool, man. Yeah. We still have the same problem now, where I'm still limited to the mouse. So there's a feature that's pretty cool. You go down here, and you can click Assign Key Map at the bottom of the screen. And it changes the screen to look like this. Assign Key Map. And then what I'm going to do is I'm going to click on this button. This button, I click on Enable for Mapping. And let's make this, I don't know, I'm choosing arbitrarily the letter A. It's now mapped. I'm going to make this arbitrarily the letter S. I'm going to make this arbitrarily the letter D. Okay? So now, make sure I lock the patch so it doesn't do that. I've made my keyboard on my laptop into an instrument. I don't even need an external MIDI device. I could plug one in. Yeah. But especially like for things like drums or triggering events, I like to just use a button because I don't want to like miss and play the wrong key. If you've ever tried to do like keyboard drumming, right? It's easier with the little touch buttons. And that's kind of what I've created. Now, one more thing. In Max, and if you, I don't want that. No, I've never done that before. Why is my face so big? Okay, so I just wanted to move this out of the way. So in Max, you actually have a menu over here. It has little sliders on it, show mappings. And if you need to refer back to this video, for just double checking this, I support you in that endeavor. These ones are working fine with toggle, but I really like momentary switch because sometimes this is trigger mode, momentary switch. I like this one better because it feels like it works faster if I'm making an instrument. Because sometimes when I've actually done this and I've designed an instrument, because it's on toggle mode by default, there's actually like a speed limit to how fast it can actually take the input. But if you switch it to momentary switch, like I did, okay. Does that make sense? Your assignment, and I'll write about this. I'll write about this formally on the website and on Canvas. The assignment for this week is to basically create a Max patch that is a musical instrument, and I would like it if you would use at some point in there some kind of either random number generator to send random values, and or certain conditional math and logic operators. Remember when we talked about if statements and EXPR math expression things? I encourage you to review the video if you're rusty on that, because that's from last week's lecture. Great. That's all I have to say about this right now. We're not done though. There's still 3 minutes. I'm gonna use every minute because again, this class should meet twice a week, but it doesn't. Question: who has used Logic before? Who has used Logic Pro? Oh, okay. This would be okay. A couple people. Yeah. If you're in my guitar studio, you have a little bit of an advantage because we tend to have our lessons in here and we use Logic. Yeah. What's up?
Why not also use Ableton? What's wrong with Ableton?
Nothing wrong with Ableton. Absolutely nothing wrong with Ableton. That is a good question. I think I single out Logic and Pro Tools just because they have more of a share of use in studios. For a long time, Pro Tools was the only game in town. Logic has come an extremely long way, and actually is like a rival to that. Ableton absolutely is a DAW and can be used for recording things for sure. Not discriminating against Ableton whatsoever. If you think about it, with Macs, we actually have the guts of Ableton, really, just with less of the pre-made affordances that Ableton Live produces. Yeah, I wish there was more time in our class, because actually that is one I would like to actually have time on, but our time is tragically limited. Yes, many of the things that we'll talk about in Logic and Pro Tools will cross over to Ableton. There are some things that happen quicker and easier in Ableton than Logic and Pro Tools. I fully admit, yes. But there's just not enough time. I want people to be able to use at least one of those two major DAWs in case you show up in a studio and someone's using something. Anyway, so darn it, we're out of time. Check it out. I'm going to make a short video limited at 20 minutes to half an hour of the stuff I actually also want to talk about today. Watch it at some point at your leisure. I'll put it on the website just as an introduction so that we can hit the ground running with Logic next week. And a lot of the same principles of Logic are going to cross right over into Pro Tools. Okay, that is all the time we have for today. Darn it. If you have any questions, please email me or come to office hours. And I'll see you then. Okay.